Container revolution. Think back to how we used to deploy applications. We relied on virtual machines, large, heavy, slow to boot, and extremely resource-hungry. Each one needed its own full operating system. Then came containers. Lightweight, portable, blazing fast to start. Suddenly, teams could pack many more workloads onto the same hardware. But here is the catch. Once you have thousands of containers running across hundreds of servers, how do you keep track of them all? How do you make sure they are talking to each other correctly? How do you recover when one crashes? You need an orchestrator. And that is exactly what Kubernetes is. The control plane. Every great system needs a brain. In Kubernetes, that brain is called the control plane. It has 4 key components. First, the API server. This is the front door for literally every command. Whether you are using kubectl, a dashboard, or any other tool, every request flows through the API server. Second, the scheduler. Think of it as a matchmaker. When you need to run a new workload, the scheduler looks at all available nodes and picks the most suitable one. Third, the controller manager. This is your watchtower. It continuously checks whether the actual state of the cluster matches what you asked for. If something drifts, it corrects it. And finally, etched, a distributed key-value database that acts as the single source of truth. Every piece of configuration, every status, every secret, lives in etched. Worker nodes and pods. If the control plane is the brain, the worker nodes are the muscle. This is where your actual applications run. Inside each worker node, you will find pods. A pod is the smallest deployable unit in Kubernetes. Think of it as a protective bubble that wraps around one or more containers, giving them a shared network and storage environment. Your container lives inside the pod. The pod lives inside the node. Each worker node also runs 2 important agents. The kubelt is the on-site manager. It receives instructions from the control plane and makes sure all pods on that node are healthy and running. And the kubeproxy is the network guard. It manages all the routing rules so that pods can communicate with each other and with the outside world. Self-healing and auto-scaling. This is where Kubernetes earns its reputation. Let us talk about self-healing first. In a traditional setup, if a server crashes at 3 in the morning, your application stays down until an engineer wakes up and fixes it. With Kubernetes, the moment a pod or node fails, the control plane detects it immediately. No alerts. No human needed. It automatically spins up a brand new replacement pod on a healthy node. Typically within 30 seconds. That is self-healing. Now let us talk about autoscaling. Imagine your application suddenly gets a traffic spike. The horizontal pod autoscaler watches CPU and memory metrics. When load increases, it adds more pods automatically. When traffic drops, it scales back down to save resources. No manual intervention. No over-provisioning. The system breathes with your traffic. Let us bring it all together. You now understand the full Kubernetes architecture. The control plane is the brain. It commands through the API server, schedules work intelligently, watches over state with the controller manager, and stores everything in etched. The worker nodes are the muscle. Your applications run inside pods, managed by kubelets, connected by kubeproxy. And the whole system is resilient. Self-healing when things go wrong. Autoscaling when demand grows. This is why Kubernetes powers some of the largest applications on the internet today. But knowing the architecture is only the beginning. In our next video, we will get practical. We will write your very first YAML deployment file and actually deploy something to a cluster. Make sure you subscribe so you do not miss it. See you in the next one.